here for the assignment 2 helper video. You'll note that I have opened the assignment 2 PDF, the A-star lecture notes, which has the pseudocode for A-star that you can also find very similar pseudocode on like Wikipedia. And also I have Unity Hub open. I'm going to go ahead and get Unity opening up while I do some of this other stuff. So I already went over the assignment PDF in class, so I don't really want to go over this at a low level, but just at a high level, right? You are going to have to be implementing A-star so that you can move around this map a little more cheaply. You're going to have to make use of two classes, graph node and A-star node. You have to make use of these classes. And also there's a priority queue data structure here that I'd like you to make use of for the open set. The important thing to note about priority queue, if you haven't noticed anything else, is that even though the pseudocode says that we are going to have a replace function, priority queue does not have a replace function. So instead, your best bet is removing some item and then enqueuing the replacement item. Now, we'll get to some specifics about that in just a second. Now this is open. Let's go ahead and open it up, do some clicking around. So this is the same thing I did at the assignment. So just by going like that far, that was like 1,700, roughly 1,800 nodes. When you're done with your implementation, that's gonna be like 18 nodes, right? I just cap out there at the maximum that I can possibly look at when I try to look across. So that's not great. That's not ideal by any means. And your job is to fix that, basically. I'm gonna go ahead and get that opening up. While we're sort of working on getting that opening up, the basic thing that we're going to want to do, right, is implement this pseudocode. Okay. Let's actually go ahead and reference the current A-star. Here we go, current A-star Pathfinder. Just one-to-one, check this out. So we have here, add start to openset. That is equivalent to openset.enqueue start. All we're doing here is we're saying, hey, here's the location that we're starting in. Here's where we're going to start the search process. Then, while the open set is not empty, that is equivalent to here, while openset.count is greater than 0, which is equivalent to checking if it's empty, right? Because then it would be 0 if it was empty. We also have a limit in terms of the number of temps. You can get rid of this, but it really, truly should never be an issue when you have the correct implementation. Unless you have some sort of weird sort of scene you've made yourself in which there's some kind of navigation that's impossible, at which point, maybe you keep that just so you don't have an infinite loop. But you don't need to do anything with it, basically. Then we have current equals openset.pop, so that is equivalent to the openset.dequeue. This is equivalent to the pop function that gets us our current node. When we first have our iteration, right, this has to be the start node, just like you all ran for the quiz 1. But later on, this will be different nodes. We're going to check and see if that node is the goal location, and if it is, then you get to reconstruct the path. You don't have to worry about this. This is already done for you. This is this part of this code. Then we're going to check each neighbor. Now you'll note we're missing something here. We're missing adding this to a closed set. And in fact, if we just do a quick check, there's no closed set in the script. So that's a thing we're going to have to add. So let me go ahead and just mark that as a thing we're going to have to add. Mark it in pink, obviously. We all know that's what the color means. Then we want to iterate through the current sort of neighbor of the current node. That's already done for us. That is, whoa, I've already lost myself. Right here, iterating through the current node's neighbors. Check and see if it's in the closed set. Obviously, that's not happening because there's no closed set. We want to calculate the G-score. That's happening right here, calculating the G-score. We want to check, hey, if it's not in the open set, go ahead and add it to the open set. We're not doing that, right? All we're doing is just directly enqueuing it as soon as we find it. So this is missing. Oh, I guess I should mark this as well. And then, of course, we don't have this else if right here, which is the if the G-score, aka the distance that it took to get to this node, is less than an equivalent neighbor already in our open sets, G-score, the distance that it took to get there, then we want to replace it. Okay? So that's it. It's 1, 2, 3, 4, 5, 6, 7 lines of code that you need to implement for this assignment. Besides that, let's go do a quick check back over here and go take a look at everybody's favorite part, grading, or marking if you like. So the homework assignment is worth 10 points. As per usual, all those homework assignments are 10 points. Your solution will be graded by an autograder, as always. The autograder will attempt to have Pac-Man navigate from various points across each map. For each map that your solution is tested on, 1 point will be deducted if your implementation expands more nodes than is necessary, aka if you did not implement A* correctly. This actually, it's a little bit nicer than this. You do get a partial points if you're slightly off. So don't freak out too much if you're not 100% perfect. As long as you're close, you'll do okay. The autograder will test your solution on 10 maps. Notably, this is a different last 5 maps that you don't get to see. So you have your 5 provided maps, 1 new map, and then 4 that are the same from last time. And there's 5 withheld test maps. These are different test maps. That's important because I don't want you thinking, well, if I know something about where my grid handler failed, I know something about these maps. No, they're totally new. For the given 5-map scene, I've gone ahead and given you my expected amount of nodes that you would open, going from the top left to the bottom right corner in terms of the number of nodes that you create. Now, this is important. This is being measured in terms of the number of nodes that you're creating, aka expanding. That's just a different fancy way of saying creating these nodes. This means that every time you call A* nodes initialize or constructor function, right? This function, that's creating a new node. So you want to minimize how many times you are calling this function, which if you take a look, is happening for every single neighbor right now. That's why there's so many of them. Okay, in addition, there is extra credit, but let's get to the extra credit in a bit. Before we get there, I wanted to go over some of the hints, because last time, I think some people just didn't check the hints out, so I'm going to make you check the hints out by having it in this video. For the extra credit, heuristic, we're going to get to that in a second. It is good to test your technique on new maps. You can make your own new maps. I can show you in just a second how to do it. All you want to do is, actually, no, I can't, because that would involve showing you a grid handler that isn't busted. So never mind, I can't. But on your own, solution, your own project, as long as you're using your own grid handler.cs file, you can make changes to like obstacle test 1 points.cs, and that'll change the obstacles that are present in scene 1. So if you want to test it on other maps, you can that way. Though in this case, you won't know if you're sort of opening up the correct number unless you check that by hand. So you won't know how many nodes you should be initializing unless you've determined that ahead of time, which you can do. It just might be a little bit more work. This is the important bit that I said we were going to get to later in terms of the open set with the priority queue. Remove the function in your priority queue in the open set takes as input an A* node, which has to exactly match the node you wish to remove. However, you don't want to instantiate additional A* nodes for this assignment. Thus, it might be helpful to keep track of your A* nodes in an additional data structure. So that basically means that we need an additional way to track our A* nodes that we've already created so we don't have to create new ones as much as possible. I'm not going to show you this. This is just me giving you a big hint of like how to do this. You will need to make your own data structure for this assignment. I'm going to show you one example of that in a second, but I would recommend reviewing lists and dictionaries. If you, for some reason, like just don't know what a list is, right? You had to use it a little bit in the last assignment, but if you don't know, the Microsoft Docs are really good. So this is for the list class. It has a lot of information about how list works. There's also the exact same thing for dictionary. So I recommend checking these things out if you need a primer for these things. This is not a data structures class. I will not be teaching you data structures, except specialized data structures for game AI. But otherwise, I'm not going to. And then finally, submission. To submit your solution, you just need to submit your modified A* Pathfinder. That is literally it. Don't give me anything else, please. People generally did a good job with that. There's only a few people who messed that up for assignment 1. Okay, so let's jump back over to here. Back into Unity, actually. Let's take a look back at our pseudocode and the lines that I marked. So we mentioned closed set. Closed set is a thing that we don't have. So I'm going to go ahead and I'm just going to give you closed set. I'm going to give you 3 of these lines of code. This is how much this last bit is probably going to give you trouble. I'm just going to go ahead and give you these 3 lines right now. Check this out. So what we're going to need to do is we're going to need to initialize a new list. This doesn't technically have to be a list, but I think it's going to be easiest if it's a list. So what we're going to do is, now you might think we could use an A star node. This would make it a list of A star nodes that would be creating here. Let's go ahead and do that for now. Let's first start with just making it an A star node list. A star node. Okay, so now I've initialized this list, so this is just an empty data structure, and I can add things to it as I like. So if we do that, we can go ahead and check and see. Okay, so what we want to do is check and see if our neighbor is in our closed set, and then continue. So, okay, so here we go. If our neighbor is in our closed set, first we need to add it to our closed set, so that's pretty straightforward. Just do closed set dot add, and then cur node. There we go. So that's going to give us that part. And then down over here, right, we need to check and see, hey, if our neighbor is in our closed set, then we don't want to do anything with it. Now, this is at a slightly wrong position, right? Typically, I should be putting this up here, right? So I should be saying, like, if, A star node dot contains, and then passing in neighbor. But there's a problem with that, and C# is immediately going to yell at me, because neighbor's type is graph node. So our only option is to actually put that check down here and pass in A star neighbor instead. Now there's an immediate problem here, because that means we have to initialize an A star node, or an A star neighbor. So it's not really a huge benefit in terms of the number of nodes we open. In fact, if we go back to Unity and I play it, and I click some places, you can see I've cut down a little. Oh, geez, it's taking so long. No, I really haven't cut down that much, huh? Yeah, it's basically the same amount of nodes. Yeah, it wouldn't have been cut down, because we're still initializing the same number of nodes. We're still initializing the same number of A star nodes. What we really want to do is be able to check if we've already been to this graph node, not if we've already been to this A star node. So that means we're going to have to make some changes. We're going to want closed set, instead of being a list of A star nodes, we want it to be a list of graph nodes. Now, this is going to yell at us because the types don't match up, right? But that's pretty easy. We can just grab the graph node from cur node and add it to the closed set. Then, now this is going to yell at us. We can go ahead and do this up here. Okay, so now if we go back to Unity, and I go ahead and just click someplace, way better already. I don't know if you can see, but we're already about, a third less, maybe even more in terms of the number of nodes you're using. I've given you all of that. Because this last bit is so tricky, particularly this bit. This is going to be the thing that I think the most people are going to need help with if you need to come to the help session, which I guess will be Friday night. If you need other help, message me on the Discord. But otherwise, that's the basic idea for this assignment. Before I go, I wanted to talk a little bit. That's completely wrong. I wanted to talk a little bit about the extra credit, because as a reminder, you can get up to 1 point of extra credit for implementing a better heuristic than the one currently implemented in heuristic. So let's go ahead and take a look at that. So if we go to heuristic, by the way, I'm not going to upload this code. It's like 4 new lines, 5 new lines of code. You can copy it down. At least, come on, folks. Don't just copy and paste. Think about the things you're doing. I believe in you. Okay, so let's take a look at heuristic. So right now, the heuristic is the Manhattan distance, which is just the absolute difference between the current location and the goal location in terms of the x value, and the current location and the goal location in terms of the y value. And that's it. And this is one of the reasons why our numbers are so high. Now, notably, these numbers come from using that default heuristic, so you should check these numbers with that heuristic before you make any changes for the extra credit. As per the usual, the extra credit is the harder part if you want to do it. It may be not harder in this case. I think that the balance is a little bit more even between the two, but it's definitely you have to be more creative, or at least think deeply about what's going on. Anyway, the basic idea here is that the best student implementation, in terms of the fewest nodes explored with the instructor A* implementation, and any implementations within 10% of the best will receive 1 extra credit point, and all other implementations will receive a fractional percentage based on their relative performance. So if you are not within 10% of the best, if you are within 60% of the best, you'll get 0.5 extra credit points, and so on. But you will be guaranteed to at least get 0.1 as long as you do better than my provided heuristic, as long as you do better than Manhattan distance. And this is super easy to check, right? Do some clicking with Pac-Man with this heuristic, and then change it and do the same test and see if your numbers go down, right? You just want those numbers to be as low as possible. And you want those numbers to be as low as possible across multiple maps, not, right? Because there's going to be particular situations where your heuristic might be better, but you need to be general, because that's what I'm going to be testing on. I'm, in fact, going to be doing the same tests that I do for this part, but with different heuristics. So I just do it all at once. Quick note, because I've had some issues with this with students in the past, you cannot change the input arguments or the returned value type of heuristic. Further, you should not change calculate path such that it relies on your specific heuristic function. It should be able to run without crashing with the default heuristic function. This is just important for me testing this part of the assignment, okay? I think that's basically it. As I mentioned, we'll instead be having a extra help session on Friday night. I'll send out information on that in an email when I send this out. Otherwise, hit me up on the Discord, hit me up on email, ask me questions after class, etc., etc., etc. Thank you all. Hope this was helpful.